Hello, my name is Carlton Doe, and thank you for spending a couple of minutes with me today. We're going to talk about some of the most powerful data processing technology IBM has in their portfolio, what we refer to as the IBM Internet of Things engine, also commonly known by its product name, Informix. Informix is different than other database engines you might have run into in the past. It is not a strictly relational database engine, but it is actually an object relational database engine, which means it can do things that other database engines can't. For example, one of the most popular technologies today is referred to as Internet of Things, which uses unstructured data, data that's typically in a JSON format, where from one document to another, the schema or the structure of the data might change. These data types are typically stored in silo engines that can only handle that type of data. But the IBM IoT engine, Informix, can actually handle that unstructured JSON data as well as structured data. So you can combine both of them together in the same database and even in the same query. And what I'm going to show you today is an example of how that works. It is not uncommon in today's world to have a number of sensors, whether it's in your car, whether it's in a home environment, whether it's at work. They can be as small as something like this. This is an environmental sensor that captures things like temperature and humidity, the amount of light that's in a room. There's about 12 or 13 different sensors in this. And it can produce data, this sensor type data, in this JSON or unstructured format. And the problem becomes, what do we do with this data? How can we bring it into our corporate environment and do something with it? Whether it's to analyze for trends, whether it's to look for exceptions, somehow we've got to be able to use this data. To try and capture millions of these devices into your data center would be a lot of work. So what a lot of customers are looking at doing is installing a gateway device, something as small and simple as a Raspberry Pi. Now, on this Raspberry Pi, you would need to have some sort of a full-featured database engine that could handle both structured and structured data, and that's very hard to come by. As a matter of fact, there's only one that can run on an environment this small and be able to handle everything that you would need to do with that data, and that's the IBM Informix engine. This engine can scale from as small as the Raspberry Pi all the way up to the largest servers that can handle millions of transactions a second. And on this Raspberry Pi, it's the same engine. The same functionality that you would expect on the largest server is available on this environment here. So what I'm going to do today is show you how you can capture data from this device, bring it through a gateway environment and into a corporate system. And I have a little setup over here that kind of mimics that. I have my sensor, I have a gateway device, and I have my corporate environment. Now this could be on-premise, it could be in the cloud, it doesn't matter. And so what we're going to do is we're going to transition the data from one into the other. So switching now to my screenshot, you'll see that I have two windows open. The window on the right here is actually connected to the Raspberry Pi that you see on the desk. And as you can see, there is an Informix engine up here. It's up and running and turned on. The window on the left is my corporate server. Whether it's in the cloud or it's on-premise, it doesn't really matter. What I'm going to do now is show you how we can grab the data and put it into this environment. Now, I could do this by writing C programs or something along those lines, but let's make it a little bit easier. Let's use Node-RED. Node-RED is a Java application that leverages a number of open source technologies, and what I'm going to do is create a very simple, what's known as a flow. And in this flow, we're going to be able to look at a number of different things. So what I want to do now is grab some elements out of Node-RED. The first thing that I'm going to grab is a tag, or is an element that can actually communicate with my sensor. Now then, I have a sensor here in my hand with a battery. It's timed out, so I need to restart it. And given that this is a live demo, of course, it might not work. So you can see now that in my environment, the Node-RED is recognizing that I have an environmental sensor. What I am most interested in is just the temperature component of what's coming off the sensor. So I click those buttons and say done. When I hit deploy now, you can see that Node-RED has recognized this sensor and is now communicating with it. What's it actually bringing off disk? Well, we wire in a debug node here and hit deploy. And we can see now in the debug, oh wait, looks like the sensor tag is timed out for a second. There we go. Okay. Now that we've wired these two together, you can see that the sensor, or the Node-RED sensor element, is reading the tag. In my debug area now, you can see the data that's flowing off of the sensor. I'm only interested in the temperature part, so I'm getting a unique identifier off the sensor, I'm getting a timestamp, and I'm getting two temperature values that are stored in NoSQL format. So there's a temperature sensor that senses the temperature of the board itself, and another temperature sensor that is sensing the ambient temperature of the room. So we know that Node-RED can talk to the sensor. Now then, let's actually store this sensor data in the database. So we go to Node-RED and we pull out a specialized element called time series. Now, most IoT data is stored in time-oriented format. In a traditional relational database, that means you have to have a row for every single ping off the sensor. IBM Informix has a specialized data type that allows you to store this data much more efficiently, as you'll see in just a second. And that technology is called time series. So I'm pulling out a specialized element from Node-RED that knows how to talk to time series. Because I've run this demo already, it's partially pre-configured with the correct address for the Raspberry Pi and the port and so forth. All I need to do is put in what the table name is, which in this case is sensors. I save the data, I connect the sensor tag to the insert statement, I deploy, and Node-RED says that we're successfully inserting data, but let's check to make sure. So for that, we go back to our Raspberry Pi environment and we run a very simple SQL statement. And lo and behold, I am capturing sensor data into the database. This SQL script runs every couple of seconds, and you can see by the timestamp that the sensor is pinging about every second, so that we know we have data going into the database. Let's stop the insert for just a moment, and let's actually look at what that time series data is. So for that, we run another real quick SQL statement. And as I said, in a traditional relational database environment, each one of these elements would be a separate row, and it would generate a table that is extremely tall with millions and possibly even billions of rows of data. In Informix time series, all of these elements are stored in a single row. We have a way of indexing into a position in that array. It's very, very simple, very, very quick. Well, that's great. We can capture data off of our sensor. We can put it in a gateway device. How do we get it into our corporate server, though? What can we do with it once it's there? Well, with other technologies, you'd have to buy a series of extract and transform utilities, and you'd have to put together this whole infrastructure related to moving data. With Informix, all of that technology is built in. You don't have to do anything extra to it. As a matter of fact, Informix has 4 built-in replication technologies. And what we're going to do is we're going to leverage one of them. And I'm going to run a shell script here real quick that sets up the technology. So in Informix, we have built-in technology for high availability. We have replication that is selective, so you can define what data gets replicated where and when it moves. We have another type of replication technology for managing large clusters. And we have another technology that allows you to shard both NoSQL collections that are stored in Informix and regular SQL tables, which is kind of like a massively parallel processing or MPP environment. So what I'm doing now is I'm setting up the what, where, when type of replication. It's called enterprise replication. And it takes a few minutes for the Raspberry Pi and our corporate server to talk to each other. But you can see now that they are both connected to each other and they're up and ready to run. Well, we don't necessarily want to move all of the data, all this second interval data out of our gateway into the corporate server. What we want to do is send out just some aggregate data. Well, can we aggregate? Absolutely. There are aggregate routines built into Informix that allow you to do that. But what we're going to do is leverage the power of Node-RED to build an aggregate on the fly as data is moving into the database. In order to do that, we have to define what table the aggregates are going into and the fact that we want that data to replicate. And this is the command for how that's done. Again, it's a simple SQL statement that says we want to define replication, and we want data out of the sensor's average table to move from the Raspberry Pi to our corporate environment. So what I'm going to do is run that right now. So what is happening at this moment now is the Raspberry Pi is talking to my corporate server over here, making sure that it has all of the database objects and everything else it needs to receive this replicated JSON data that's being stored in NoSQL. So we'll give this just a second. We can see the verification is complete. So the replication rule is now defined, and we're turning it on, and this is just a status message that says it works. Well, how can we leverage this aggregate? We go back to Node-RED. And the easiest way to do it is to use a flow that I've already pre-built. Okay? In this flow, I have an element that says, every 10 seconds, I want you to wake up and do something. Well, what is that something we want it to do? What we want to do here is dive down into the JSON data that's coming off the sensor, grab the ambient value, and perform a 10-second aggregation on it. Once that's done, it moves into this element that says, I want to extract just the temperature component out of that time series data that's been aggregated. And then I want to reformat it into a new JSON document that I can populate into the average table, the aggregate table, and then push up to my corporate environment. Finally, the last step is to actually insert the data into this average table. So with all of this work done, what I'm going to do is drag these elements down so they're easier to see. Oops. And I'm going to turn back on inserts. So I'm now inserting data back into the database. How do I know? Well, I can run my check script again. And sure enough, my data values are changing here. So now I can turn on the aggregation. And I deploy that. And Node-RED says it's working, but let's check. So we go back to our Raspberry Pi environment. And sure enough, I have my first two aggregates on the fly as the data was flowing into the environment. So here's the first 20 seconds worth of data. Here's the first 30 seconds of data that's flowed in. So we know it's being stored on the Raspberry Pi, but is it being replicated into my corporate environment? So now we check on the corporate server, and lo and behold, it's there. The same values that existed on the Raspberry Pi also exist in my corporate server. I didn't have to buy any additional technology. I just leveraged things that were built into Informix. So with this, we know we have some data values. We can stop the inserts. Now we get to the fun part. Okay, so we've got about 30 or 40 seconds worth of data inserted into my corporate environment. Notice that it has a timestamp and it has some data in JSON or NoSQL format. But in your corporate environment, you have standard relational data, things like a customer table. And this customer table has standard relational data. Can you join standard traditional data with your replicated time series JSON data? There's only one database engine in the world that can do that, and that is Informix. Let me show you what's on the corporate server. So here's my time series data, the JSON data. So can you join this NoSQL replicated data with standard traditional data? Absolutely. What I want to do is show you how that happens. This is the SQL statement that's going to do the work. You can see that I'm selecting some relational data from the customer table. Now I'm diving into the time series and I'm pulling out the timestamp value and I'm formatting it the way I want to see it. Then I'm diving into my NoSQL data and I'm pulling that out as well, and I'm joining between the customer table and the NoSQL data. There is no other engine in the world that can do this. And it's all being done in a simple SQL statement. Or so it appears. Let's check and find out. And lo and behold, there you have the result. Relational data, NoSQL data that started on a sensor environment that got captured by a gateway device and an enterprise-class database engine that was replicated and aggregated in real time into a corporate server, whether it was on-premise or in the cloud. And now you have the power to leverage both your traditional data and your NoSQL data in a single statement to produce a consolidated result. And there's only one engine in the world that can do that, and that's Informix. If you have any questions, please contact your IBM sales team or technical sales team or sales partner. We'd love to explain more about how this works. I'm Carlton Doe. Thanks for your time.